Welcome to the Human Experience Podcast, the only podcast designed to fuse your left and right brain hemispheres and feed it the most entertaining and mentally engaging topics on the planet. As we approach our ascent, please make sure your frontal, temporal and occipital lobes are in their full upright position. As you take your seat of consciousness, relax your senses and allow us to take you on a journey. We are the Intimate Strangers. Thank you for listening.
I had a lot of time alone to ponder how is the natural world occurring and how did I end up in the middle of it? Like, it's a strange thing for me that all of a sudden we arrive here and we have this thing we call consciousness. And if we were to tap just 1 billionth of a % of what's in a centimeter cube of space, we could run our planet for thousands of years. The next step in the human evolution, I believe very strongly, is to actually learn more fundamentally what gravity is and learn to control it, and then free humanity from being stuck on only one planet. It's very difficult to bring new ideas to this world. Much of my work has been censored. It's extremely difficult for me to publish because it was right along the lines of what I was thinking earlier, that maybe the space is responsible for matter, not matter defining the space.
Just listen.
What's up, folks? Xavier Katana here. You are listening to The Human Experience. Our guest for today, Mr. Nassim Haramein, we get into the interconnected nature of the universe and the work that he's doing over at the Resonance Foundation. Very interesting episode. I think you guys will really enjoy this one. Thank you so much for listening. The Human Experience is in session. My guest for today is Mr. Nassim Haramein. Nassim, it's a pleasure, sir. Thank you for making the time. Welcome to HXP.
Thank you. Thank you for having me.
Nassim, I've been following your work for a long time, but many people might not know who you are. Can you just give us an introduction of who you are?
Who I am is a very deep question. I think that most people contemplate throughout their lives, but I have been doing physics for some 30 years. I wrote, I think, significant physics theory that have a deep impact on understanding of ourselves, the world around us, and our relationship to the universe. Some of these theories are now confirmed by experiments, and it's a theory that unifies quantum physics with relativity, that unifies gravity with the quantum world of subatomic particles and atoms. So this was something that Einstein worked on for a good portion of his life after he wrote relativity, because there was this chasm that was generated as a result of his equations between the physics we use for the big stuff, like planets and stars and galaxy and all this stuff, and the atomic structure of electrons, protons, and subatomic particles. So after all this kind of came to bear, Einstein worked literally till the day he died. Like, he was working on it to the last minute, trying to find a solution that would unify those two physics.
Very interesting. So, I mean, this has been a problem in Western physics for a very long time. This sort of gap in understanding between the macrocosm and the microcosm, correct?
Exactly. And, the two views don't agree with each other. One says that space-time is smooth. Einstein field equation says space-time is smooth. It's curving, and the curvature of space-time produces gravity. But these equations, Einstein field equations, don't actually define exactly what is space-time, and then quantum theory says it's not smooth. It says that it's quantized, that it's discrete, that it's little bits, little particles. And so the two don't agree. And that makes it so that we can't find a way, or so far, it hasn't been found, either than what I wrote, a way in which gravity, which is Einstein field equation, can be applied at the quantum level of the subatomic particles and the particles that makes up the material world. But the thing is that the big things that Einstein field equations deal with, like planets and stars and all this stuff, is all made out of small stuff, like particles that makes the quantum world. And so really it's a deeper question. And it is a question of how is the quantum world able to organize to make the what's called the classical world, or the larger macrocosm that we experience every day. And that leads to even deeper questions, which is, what is the source of organization? How does things know to come together in certain ways that make it possible for us to even be here and to be able to ponder the question in the first place,
Right.
And so that is very profound. And you would expect a theory that would unify the fields of relativity and quantum physics would answer some of those deeper questions about, for instance, biology. How does biological system all of a sudden self-organize? It's a big mystery. Biological systems are very complex, and for them to occur under random function is very unlikely, extremely unlikely. And so what is the source of their organization? How do cells know to divide in livers and hearts and everything else to produce an organism with 100 trillion cells, like a human being, with a 1,000 billion chemical change every second that makes everything work just fine? All these things are unanswered questions that you would expect a unified view of physics would start to answer. It would start to tell us what is the source at the very profound, at a very fundamental level.
How did you get into solving this equation? Like, why did you feel this draw towards solving this equation?
Early on, when I was a kid, I didn't fit in very well into the educational system, into society in general. I was kind of an odd kid. I was in Canada. I was odd in the way that the color of my skin and my name was odd relative to the people there. I have a Persian name. Iran at the time was unknown almost. Most people there didn't even know there was a country with that name. I was born in Switzerland. I was never in Iran. But, even being from Switzerland, I had a different culture at home. And I thought differently. I was very interested in nature. And because I didn't have much interaction with the external world, I developed a sense of my internal self in relationship to nature, in which I pondered a lot. I had a lot of time alone to ponder, how is the natural world occurring and how did I end up in the middle of it? Like, it's a strange thing for me that all of a sudden we arrive here and we have this thing we call consciousness, and we're able to interact with this world. And it's like, how did this all happen? How did I get here? What is this thing I call my consciousness? And how is this world coming together? And so I sat in meditation, thinking about those things a lot. And when I did, when I observed nature, or even when I observed people, I could see there was pattern. There's one thing I could see that seemed to be everywhere, is that there was patterns, that like the patterns that the branches of a tree, the patterns that makes the leaves of a flower, the way people interact when they walk together, or, I could see all kinds of patterns. And I thought, well, these patterns must emerge from somewhere. I mean, it took me years before I realized, yeah, those patterns are actually based on mathematical constants that you find in nature, like the way branches divide, the way roots divide, the way your fingers grow, the way, your arms relative to your body are very specific ratios. Like all these ratios that nature seemed to use points to some kind of fundamental geometry that must be present,
right,
to produce those patterns. And that intrigued me. And I wanted to understand it. I wanted to know. And those questions were not the typical questions that 10-year-old asks. So I wasn't getting answers to some of these questions, and I was really inquisitive.
right,
That
right.
launched me into really kind of examining some of the fundamental assumptions we make about reality,
Hmm.
and to think that there may be places where we missed important axioms that makes up the way we write math, the way we write physics. If we modify those axioms a little bit to actually match better what we observe in nature, we would get to different conclusions. And so I explored that in depth.
Why not pursue this through a traditional course? Why not pursue a PhD with a university or something like that?
Because I didn't fit in very well in the educational system, and funny enough, my father is a child psychologist that was very much involved. He was the director of the child psychology section at the University of Montreal for years. He did his PhD under Piaget, which is the father of child psychology. I was the perfect study case, because I just didn't fit in well. I eventually, early on, had to leave the educational system. I got into the ski industry. I was a professional skier for many years, a professional climber. I was backcountry guide and all this. And, and because I loved nature and I loved being in nature, all through those years, I continued pursuing this lifelong quest to understand the basis of reality, the basis of nature. I realized when I finally, choose to dedicate my life fully to that endeavor, I realized that if I were to go back to the educational system, I would have to accept very specific ways of thinking, very specific ways of thinking about the world that I was not willing to compromise. I wanted to learn, but I wanted to learn in a way in which I could make my own opinion about what was being taught.
Okay.
And I didn't feel like the standard educational system was going to allow me that latitude, that freedom, because the search was mainly for self-satisfaction. I was not even thinking that I would ever publicize it or talk about it in the public or anything. It was for my own self-satisfaction. So instead I decided to study independently, use the university libraries and the university resources that I could get to learn. So I sold all my equipment. I let go of all my sponsorships. I mean, I had risen to fairly high levels of proficiency in the ski industry. I was one of the top rated skier in Canada, and I let it all go, and I moved into a van, and I spent 5 years in a van, traveling around, mostly staying put in desert area and mountain areas, and studying some 15 to 20 hours a day. It was very, very intense. 7 days a week, 5 years nonstop to catch up on all the physics and all the math and all the ancient civilization that I was studying as well, and everything I needed to study and be able to move as fast as I could in trying to elucidate this great mystery.
So Nassim, I really want to get into what we call reality, the nature of reality. I got a chance to watch The Connected Universe last night, and something that you talk about in that documentary that you produced was how empty our reality is. how space makes up most of what we see in the observable world. Is that accurate?
Yeah, exactly. That was one thing that had shocked me the most when I was in high school before I dropped out, was that I asked, I think it was my chemistry teacher at the time, what is matter made of and what is the percentage of space in matter? And I was very, very much shocked to find that the material world, the chair you're sitting on, the desk, everything, the walls, everything is made out of 99.99999% space. And the things that we're saying is not space, is not really anything like physical. It's actually electrostatic fields that are interacting with each other. And because they interact with each other, it appears solid to us. So we call it matter, but it's not actually stuff. It's actually just charge or fields in the space. And so I started to think, even at the time when I was about 13 or 14, I started to think that maybe we should study the space. Maybe it's the 99.9999999% that makes up the space that's providing the energy for the rest of the stuff that we call matter. And so that was really kind of a launch point for me. I started to think maybe space is not empty. Maybe space is full of energy.
Okay, and you're talking about the vacuum? Is that what you're referring to?
Yeah, so eventually in physics, I realized that the fullness of space, the energy in the vacuum, was discovered almost 100 years ago, and that space in quantum theory, in quantum field theory, is not empty at all. It's full of energy, and not a little bit full, it's extremely full of energy. So people might have a hard time visualizing that. So for the listeners, I'm going to give you a visual. The space you're in right now, for instance, is full of electromagnetic fields. It's got radio waves, it's got infrared, it's got galactic cosmic rays. It has all kinds of stuff happening in it. And because your senses are not necessarily tuned to those frequencies, you don't realize that there's all this stuff going on in the space around you, or even in the space inside you. Now, since atoms are 99.99999% space, like you're made out of that space too, and you got to remember that. Now, if you think about all these electromagnetic waves that are going on in the space around you, you can imagine that there's higher and higher and higher and higher frequencies where the wavelength is getting shorter and shorter and shorter, and the energy levels are going, is getting higher and higher and higher, right? You can imagine that. So it was found in quantum field theory that actually you can't get space to stop oscillating, meaning if you try to get rid of all the electromagnetic fluctuation and cool the area even to absolute zero, you still have oscillation. It's called Planck oscillations. They're called Planck because they have the Planck length in wavelength, and it's a very, very small value, meaning it's a very, very high frequency. If you were to take a little Planck oscillator and you grew it to the size of a grain of sand, then the proton, which is teeny in the middle of an atom, would be from here to Alpha Centauri in diameters. So you can imagine it's happening, these oscillation of the electromagnetic field is happening in the structure of space-time at the quantum level, like billions of times smaller than an atom. So we generally don't know it's there. But they were predicted by theory a long time ago. And it's been ignored largely because the number is insanely large, meaning the amount of energy in the centimeter cube of space, because of these little oscillations, exceeds the mass of the universe by 39 orders of magnitude. It's huge. It's the amount of energy in space, in the structure of space, in terms of electromagnetic Planck fluctuation is huge. But it's critical to quantum theory. And they can't get rid of that number. And so that really intrigued me because it was right along the lines of what I was thinking earlier, that maybe the space is responsible for matter, not matter defining the space.
David Bohm was responsible for coining the holographic universe, right?
Mm-hmm.
Okay, so I was just going to ask, why is there such a big gap in our understanding of, how can we harness this empty space?
That's the thing. So the equations, first of all, I was very intrigued because I thought, wow, if we could tap the energy available in the structure of space, and I'm going to correct your terminology there again. We have a tendency to say empty space, and what I'm telling you is that there's no such thing. So the structure of space, it's called vacuum fluctuation or quantum vacuum fluctuation in physics. If we were to tap just 1 billionth of a % of what's in a centimeter cube of space, we could run our planet for thousands of years. So it was very appealing, but more importantly, what it was leading to, and eventually what it said when I started to write the math and write the physics and all this for that, is that all of the material world is actually a function of that energy in space, of that information network that's in space. You can think of every little oscillator, every little Planck oscillator as a little bit of information. And that's where it starts to relate to Bohm's idea of a holographic universe and eventually the holographic principle that was coined by De Hoof and Sutskin, which is very accurate to describe the surface of black holes and their energy level and their temperature. And this holographic view has been growing quite a bit. You might have seen on covers of magazine, do we live in a holographic universe? Is our universe a holographic projection? We're starting to discover that the universe may be this information network that's occurring at the very fine level, at the very fine grain of space-time. So it's saying that Einstein was right, space-time curves, but if you get really, really close to space-time, if you look at the very, very small level of space-time, it's actually not smooth, but it's granular in little bits of information of a Planck length. And so I used that. I eventually, it took me some 25 years to get there, all the complexity of physics. It's hard to write a unified view of physics because you have to study many different fields of physics that usually don't get studied together, because it takes a lifetime to study only one. So I was fortunate that by studying independently, I could study much faster. I didn't have any exams or function, so I could study much faster. But eventually I realized maybe this information structure of space-time is the source of what we call the material world. And of course, if we understood these mathematics, if we understood this physics, it would change everything we do, everything we know in technology, in the way we interact with the world and how we produce energy, how we transport ourselves. We're talking space drives, teleportation. All these things became possible if this was true. So I pursued it, and eventually I realized that I could write equations, which led to the holographic mass solution, where I just looked at the information and how it behaved in the structure of space, and I could output exactly the mass of protons, the mass of electrons, the way atoms produce forces, and all this. All this just fell out of it, and it was very, very precise. And now it's been verified in laboratory.
So many questions there as you're speaking. Why is spin such an intriguing force? I've seen you cover this several times. Why is spin so key to all of this?
Okay, well, think about it this way. So imagine that space is full of these little Planck oscillators, and we're going to equate that to the water in your bath. And so you're in your bath, you've got water in there, and you pull the plug, okay? And you have a rubber ducky, right? And you have the rubber ducky on one end of the bath, far away from the plug, and it's not doing anything. It's just bopping along over there. It doesn't have any coherency. It's not doing anything you could notice or predict. It's just going up and down, and bopping. But if you bring it close to the drain, all of a sudden it's going to start orbiting, right? It's going to start orbiting the drain because water is going down the drain and the surface of the water is curving. And in that region of the bath, all the molecules are spinning together, co-moving together, producing coherency. And so that coherency is not present on the other side of the bath. So you're not seeing the rubber ducky spinning. You're not seeing the rubber ducky being attracted to anything. So you think there's no gravity in that region, right? But in the region where all the little particles are co-moving, they're spinning together, there you see that the rubber ducky seems to be attracted to the center of the orbitals, right? And you would say, oh, there's a gravitational force there, right? There's a mass there. So imagine the same thing in the structure of space. Imagine that the structure of space is all these bits of information oscillating. And imagine that like only in the region where they're coherently co-moving, then you experience them as there's something there. All of a sudden, there's a mass there. You're calling it a proton. You're calling it an atom. You're calling it, a star. You're calling it a galaxy, right? Like a galaxy is a good example that people can visualize. It's like a huge smoothie. You can imagine that the smoothie is occurring in the structure of space itself, like a hurricane, right? But you're seeing the stuff that's stuck in the hurricane, that's stuck in the spinning. But what is actually spinning is that field of information in the structure of space-time.
I'm not sure if I understand that. The field of structure of space-time, can you elucidate a little bit more?
So imagine that space-time is like a superfluid, like the water in your bath, right? And so where space-time is spinning like this, it's coherent. Like all the bits of information are coherently co-moving in that region of space. There you see it as a gravitational field. You see it as like, oh yeah, if I put a rubber ducky here, if I put a star here, it's going to orbit and it's going to feel like it's being attracted to the center of the galaxy. You see what I'm saying? Okay. If you put the same star in between two galaxies, you don't see that, right? Gravity is not pulling on it anywhere there because space-time in that region is not orbiting. It's not spinning. It's not coherent. So where spin is present is because there's coherency in the structure of space-time. There's a vortex there, if you'd like. That is what we call gravity. So Einstein was correct in his equation that gravity is like the water surface curving in your bath going towards the drain. And that's what he described. It described as space-time as a surface curving, space-time curvature it's called. But he didn't describe space-time, so eventually he didn't realize that it's curving because the bits that makes up space-time are spinning in that region. That's what's making it curve.
Interesting.
So that's why spin is so critical, because if you understand that, all of a sudden you have a very important key. This is very, very important. If this is true, that means that if you succeed in spinning space-time, you can create gravitational fields. You can create mass. You can create curvature in space-time, which means that all of a sudden you can produce space drives, or you can make things that would allow us to produce artificial gravitational field or control gravitational fields. And that would lead to a very different civilization than the one we have today. We've evolved to the level of civilization we have today because we eventually learned about electromagnetic fields, magnetic fields. We figured out how to interact with them, how to control them, to make electricity, to make everything we see in our modern society. The next step in the human evolution, I believe very strongly, is to actually learn more fundamentally what gravity is and learn to control it. and then free humanity from being stuck on only one planet.
You have been listening to The Human Experience. To hear the rest of this episode with Mr. Nassim Haramein, please get to thehumanxp.com/members. That is thehumanxp.com/members. Become a member of what we're doing, support what we do here, and thank you so much for listening.